Hi, my name is Justine Harkness, and in this video, we'll look at how to use the value of the equilibrium constant to make some predictions about where equilibrium lies in terms of the concentration of products and the concentration of reactants. Since the equilibrium constant is just a ratio of products to reactants at equilibrium, we can use the value of the equilibrium constant to determine how the reaction tends to lie. Does it favor reactants or products? Now, if we start with a very large Keq, and this would be a Keq that is greater than 10 to the fourth, what this means is our ratio of products to reactants also has to be greater than 10 to the fourth. This means that we must have a very large numerator, a very large concentration of products, and a small concentration of reactants. So when we have a Keq that is this large, greater than 10 to the fourth, the reaction essentially goes to completion, where at equilibrium, we have pretty much only products with barely any reactants remaining. We call this type of a reaction irreversible because it proceeds forward to make product. But not all Keqs are this large. If we have a Keq that's not really very large and also not really very small, somewhere between 10 to the negative fourth and 10 to the fourth, we have some products and we'll have some reactants, but we'll have significant amounts of both. And this type of a reaction is called reversible since it can proceed forward to make products or it can go in reverse to make reactants. And finally, we can have Keqs that are very small, something less than 10 to the negative fourth. To have a Keq this small, this means that we have a very small amount of product and a fairly large amount of reactant. So at equilibrium, we'll have mainly reactants with just a little bit of products. But these reactions are still reversible since they can proceed forward to make a little bit of product or proceed in reverse to make reactant. So now let's take a look at some equilibrium constants and determine where equilibrium tends to lie. So we have three parts here, A, B, and C. And for each of these reactions, we are given an equilibrium constant. And we need to determine what do we have more of, more reactants, more products, or about equal, and also if the reaction would be considered reversible. So let's take a look at this first one in part A. We have an equilibrium constant of 2, and this is between 10 to the negative fourth and 10 to the fourth. So we'd have roughly equal concentrations of reactants and products, and this would be a reversible reaction since it can go in either direction. Now in our next part B, we have a Keq of 1.8 times 10 to the negative 10. This is a pretty small Keq. It is less than 10 to the negative 4. So this means that we would have more reactants. And this would also be a reversible reaction. So we have these arrows going in both directions. Now notice in part C we have a huge equilibrium constant, 3.3 times 10 to the positive 81. This is significantly larger than that 10 to the fourth. That indicates that we would have more products. Because the Keq is so large, this is going to be an irreversible reaction, where we pretty much go only forward to create product. So now you should feel more comfortable using the value of the equilibrium constant to determine if we have more reactants, more products, or roughly equal concentrations at equilibrium.